Today let me learn about how to minimize a 5 variable function which is in the form of Ssop using K-map method. So now before moving to the simplification, let me have a brief discussion on your 5 variable K-map. A 5 variable K-map is having total 32 number of cells, where those 32 number of cells can represent their minterms or max terms. So minterms are represented with small letters, and these are a product terms with the 5 variables. So started with M0 to M31, and max terms are represented with the capital M's, which are represented with the capital M0 to capital M31. So max terms are sum terms whose functional values are 0. Min terms are product terms whose functional values are logical 1. So for example, M0, if I want to represent with the variables, all the values of all the variables are zeros. So you can represent the product term. M0 is A bar, B bar, C bar, D bar, E. M1 is A bar, B bar, C bar, D bar, and E, where E value is 1. So 0, 0, 0, 1. So here, so all the values of your min term M0 is 0. So hence we have represented all the variables with complement, whereas here 001 is 00. So 001 is your m1, small m1. So hence e1 e is assigned with 1. Without complement we have to represent. In your product m31, all 5 variables are logical 1. So hence here the product term of your representation of m31, so all the variables are represented without complement, where capital M denotes your sum term whose functional values are zeros. Now here all values are zeros, so it is quite opposite to the min-term representation with variables. So if you are assigning 0 on a variable in your max term, the variable must be represented without complement. So hence M0 is A or of B or of C or of D or of E. Now M1 is 0, 0, 1. So hence A, B, A or of B or of C or of D or of E bar, where E value is 1. So hence E is represented with complement. Next M31 is all ones, so hence 5 ones we have. So represented as A bar or of B bar or of C bar or of D bar or of E bar. So like this, so with the variables we can represent your max terms. Now, so in this session we are going to minimize your Boolean expression which is in standard SOP. So hence, so we have to map your functional values, logical ones, onto your corresponding cells. So a 5 variable K map is implemented with the use of your 2 4 variable K maps. So now those 2 4 variable K maps, so like L2D, so they will be on your top as well as in the bottom layer. So now this top layer would have your A equal to 0, the bottom layer is having A equal to 1. Now the top layer left cells are adjacent to the top bottom layer left cell. The top layer right cells are adjacent to the bottom cells right layer, and topmost row of your top layer and topmost row of your bottom layer adjacent, bottommost layer of your top layer, bottommost layer of your bottom layer is also adjacent, like this. So we have to check. So like you have a floor and a top, you have your roof and floor, so they are equally equally in length. So in this in length and width, in the same manner here A is 0 is on the top layer, A equal to 1 in the bottom layer are also adjacent. Only the variable difference will be A is 0 on top layer, A equal to 1. So total these 16 cells 0 to 15 are having A equal to 0, and 16th to 31 cell, first 31 is the last cell of your bottom layer, which is having A equal to 1. Now upon your mapping, so next we will go for your cell adjacency by checking into your large group. So we can map, we wanted to cover all the minterms, so that all the minterms covering can give you the reduced expression. Now so here the first one, we can have a group of your 16 minterms is there or not, we'll check that. So this 16 minterm adjacency is not there, so then we'll go for 8 square adjacency with M0. So M0 here, let me go for this. So now M0 is adjacent to M4, M4 is adjacent to M12, M12 is adjacent to M8, M8 is adjacent to M0, as well as this M0 is also adjacent to 16. So 16 adjacent to 20, 28 is 20 adjacent to 28, 28 is adjacent to 24, 24 is also adjacent to 16. So this is on a leftmost corner of top layer. This is also on the leftmost corner of your bottom layer. So these 4 cells on your top layer and these 4 cells on your bottom layer are adjacent. So we can form an octet. So by this formation of an octet, so it can eliminate the different variables and give you the product term, which is the common variable. Now the common terms are here. A is 0 for this first layer, A is 1 for this second layer. So hence A value is different. So this is eliminated. Whereas for BC, let me go for your BC. So for these 4 minterms, so these 4 minterms and these 4 minterms are different. So hence BC are also eliminated from your product term. Only D and E are common for this 4 minterms along with this 4 minterms on the top layer and bottom layer. Hence in your product term, so we are having the product minimal expression, which is D bar, E bar. Why this D bar is? Because D value is 0, E value is also 0. So variables in the product term is represented with complement. Next, so we also have a quad formation with M0, so with M1, and in the bottom layer with M16 and M17. So M0, M1, M16, M17 can form a quad 4 square adjacency. So now let me check for your common variables. Now the top layer 0, 1 is having A equal to 0 and the bottom layer is having A equal to 1. So which are different, so they are eliminated, and you check for row wise BC are 0, 0, hence B bar C bar will be there in your minimal expression. Next in column wise DE value is 0, 0 for 16, 17 it is 0, 1, in the same manner 0 it is 0, 0, 1 it is 0, 1. So common variable is D with the 0. So here D with 0 is common, so hence D bar is also one of the variable in your given product. So B bar, C bar, D bar. Next we have a minterm M0 is adjacent with M2, M16 as well as M8. So here M18. So now because of M0, M2, M16, and in order to cover your M18, so and M2, so we could go for your checking our large square adjacency. M0 is adjacent with M2, M16 as well as M18. Since they are in top layer, so they are adjacent, so it can form a 4 square adjacency. The common variables are B and C, so B bar, C bar. In column wise, so it is E with 0, so hence E bar. So B bar, C bar, E bar. Next minterm 7, 15 can form a pair. So here 7 and 15. So there is no possibility to form the large group, only it can form a pair. So this pair can eliminate total only one variable. Here it belongs to 7 and 15 belongs to A0. So hence we have A bar in your product term along with, so your C value is 1, so C will be there in row wise. DE are 1, 1. So hence DE variable for these two minterms row wise C value is 1 along with column wise DE value are 1, 1. So A bar, C, DE are the minimal expression. Next M14, M15, the top layer, M31, M30 are adjacent, can form a 4 square adjacency. It can eliminate two variables. Now since these two are in top layers, these two are in the bottom layer, A variable is different, so A variable is eliminated. Now BC are common variables, so BC will be there in column wise. D variable which is assigned on these columns, two columns are 1, 1, so D will be there in the product term. So summation of these all the product term will give you the minimal expression. So pair grouping, so 2 square adjacency, which is A bar C D E. Now quad grouping B bar C bar D, B bar C bar E, and B C D along with an octet formation D bar E bar is the minimal expression. Another example we also have with the given minterms. Now here using this we can do total groups or 5 groups. We can do the 5 groups here. So first group can form a quad with M0. So quad, so 4 square adjacency with 0, 16, 8 and 24. So now upon checking that, so we can have 0 and 8 are having A0, 16 and 24 are having your values are A value with 1, so A is eliminated. Now BC are 0, 0, 1, 0. So C bar is my product term in my product term, and they belong to the column, first column. So hence D bar, E bar. So first product term is C bar and of D bar, E bar. Next, second group is done with your fifth minterm. So where this is doesn't have your any cell to pair or to form a large square adjacency. Hence this is treated as your the isolated minterm. So now that isolated minterm to be written as A bar. So this belongs to the row of A bar, B bar C along with so D bar E. So your product term is isolated minterm. Product term is A bar, B bar, C and D bar E. Next group 3. So is also one more isolated term which doesn't have any pairing. So hence it belongs to the first layer. So hence A value is 0 for that minterm A bar. It belongs to the first row. So B bar C and it belongs to the last column element. So hence it is D and E bar. So D, E bar is your isolated. So this is your group 2 which is the isolated minterm. This is your group 3. Next group 4 will be formed with a pair of 16 and 20. So now that 16 and 20 belongs to A. So A value with 1. So A and of. So these two are belong to the row of 0, 0 and 0, 1. So B value is 0. So B bar and it belongs to the column of first column which is where the values of your D and E bar E are 0. So hence so it eliminates. So the pair can eliminate one variable from your minterm. So 5 variable function it is. So only 4 are there from your group 4. Next the last group A can formed by an octet which is 8, 9, 11, 10, 24, 25, 27 and 26. So these are in top layer. So 8, 9, 10, 11, 24, 25, 26, 27 in the bottom layer. So A value is different, so they will not come. So where B, C are the same row. So which is B value is 1, C value is 0. So B, C bar and here we don't have D are not same for your or they are different. So hence they may not be in your group. So by ORing these all the product terms, then we obtain your final expression. So this is the formation of your pairing and these two are the isolated minterms. So next we have here the octet formation. So like this, so we are going to have a minimal expression of your given function using your K-map method.